page, those reciprocal identities you already know. You already knew that cosecant is just sine upside down. And that's all that is written right there. Cosecant is just 1 over sine, or sine flipped over. And the same thing is true of sine. Sine is just cosecant flipped over. So you know these 6. So you don't really have to memorize them because you already know them. These identities, you kind of knew this one already. Because you already knew that tangent was y over x. And on the unit circle, sine is y and cosine is x. So you kind of knew this one already. Tangent is sine over cosine. So because of that, cotangent is reciprocal. So it's the same thing flipped over. So those two are easy. These 3, the Pythagorean identities, that's all completely new. I can explain to you later why they are Pythagorean identities, but obviously a squared plus b squared equals c squared, and the unit circle, c is the hypotenuse, and the hypotenuse is 1. So it makes perfect sense. And these fall right along in it too. It takes a little bit of deriving to get those, but that's where it comes from. So you have to know these identities. This one is huge. We will use it all the time. And we won't just use it in that form, but they can rearrange it. Like, for example, I could take this sine and move it to the other side and have cosine squared x equals 1 minus sine squared x. That's still the identity. It's the same identity. It's just been rearranged. Or we could move the cosine. It doesn't matter. So just be prepared. We're going to use this one a lot, and it'll be in all different forms. Okay, so this is how and why and when we're going to use them. We're going to use them to evaluate trigonometric functions. So on number 1, if a theta is a rotation angle that terminates in quadrant 2 and sine of theta is 5 over 13, find cosine of theta and tangent of theta. And they want us to use identities. Now we already know how to do this, and it's very simple. We could set up a quadrant grid, we could draw an angle, we could put that it passes through a certain point, and it's got sine 5 over 13, and we could find all the sides. But they don't want us to do it that way. Instead, they want us to use the Pythagorean identity to solve for cosine. So when they say the Pythagorean identity, they're talking about this one right here. So I've got sine squared, this time we're going to put a theta instead of an x, plus cosine squared theta equals 1. But I actually, this time, happen to know what sine is. It's 5 over 13. So I'm going to replace that with 5 over 13 squared plus cosine squared theta equals 1. And now I'm just solving. So that's going to be 25 over 169 plus cosine squared theta equals 1. So now I'm going to subtract 25 over 169. So I get cosine squared theta equals, I'm going to do 169 over 169 minus 25 over 169. And that would give me cosine squared theta equals 144 over 169. Now I'm just trying to figure out what cosine is, so I just have to take the square root. So cosine of theta equals 12 over 13. We could have done the exact same thing by setting up the coordinate grid and actually, on this particular problem, setting up the triangle would have been easier. But later on, the trig identities are easier. Okay, so it says there are 2 answers to this equation. Explain how you know that you should use the negative solution. Okay, right here, when I took the square root, there's both a positive and a negative answer. So when I got 12 over 13, I should have known it's not really 12 over 13. It should be negative 12 over 13. How would I know that?
Because it's in quadrant 2.
Very good. Cosine of theta should be negative 12 over 13 because it's in quadrant 2. And remember, all students take calculus. The only thing positive in quadrant 2 is sine and cosecant. Okay, so now it says to use the quotient identity to find tangent. So here's my quotient identity. Tangent equals sine x over cosine x. So I just found cosine x, but they gave me sine x in the original problem. So I'm going to use tangent of theta equals sine theta over cosine theta. So tangent of theta equals 5/13 over negative 12/13. So then you got to keep, switch, flip. So keep the 5/13, switch it to multiply, flip the 12/13 over, and I get tangent of theta equals negative 5/12. And just to check, make sure my math is right, all students take calculus, tangent should be negative. So, all right, so on number 2, it says if Q is a rotation angle that terminates in quadrant 1, and tangent of Q equals 3, find secant Q and cosine Q. Okay, so in this case, they didn't, the one above it, they told me which identity to use. They said use the Pythagorean identity, use the quotient identity. And this one, they're not telling me which one to use. You have to figure it out. So I know tangent. That's the only known information I have, which means whatever identity I use, it has to have tangent in it. So if I look at the top of the page, I see 1, 2, 3 identities that have tangent in it. So I've at least cut it down. It's got to be one of those 3. So the next thing is I can only find one value at a time. So I'm going to do secant. So I look at the 3 identities at the top of the page that have tangent. So this one has tangent, and then this one has tangent, and then this one has tangent. Well, this is the only one that relates tangent and secant. So that has to be the one I'm using. So I'm going to use that Pythagorean identity, 1 plus tangent squared q this time, equals secant squared q. So that's going to be 1 plus, I know what tangent of q is, it's 3. So it's going to be 3 squared equals secant squared q. So now I have 10 equals secant squared q, but I'm just looking for secant. So you're just going to take the square root of both sides. And I get secant of q equals the square root of 10. It's in quadrant 1, so it should be positive. Everything's positive in quadrant 1. All right, so I did secant. Now I need to find cosine. So remember, the given information that they gave me was tangent. But now I actually have more known information, because not only do I know tangent, now I know secant, because I just found it. So I can go to the top and I can see what do I know, what can I do to find cosine if I know tangent and secant. So let's see, I'm looking for cosine. Here's one that has a cosine in it. That's cosine and secant. Here's one that has a cosine. That's cosine and secant. So that definitely has pieces that I know. I'm just going to keep looking though just to make sure. Here's cosine. It's got tangent in it, and I do know tangent, but it also has sine in it, and I don't know sine. So that one doesn't help me as much because I don't know sine. Here's cosine. It's got cotangent and sine, and I don't know either of those. Here's cosine again, but it's just sine, and I don't know that one. So that means it's got to be one of these two, because they're the only ones that relate cosine and secant, or only one piece of the known information that I have. And honestly, either one of them will work. The easier one to use is cosine, because that's the one I'm looking for. So I'm just going to write cosine of q, because that's the letter they gave me this time, equals 1 over secant q. I know what secant of q is, so that gives me cosine of q is 1 over the square root of 10. I just have to rationalize that now. So I get square root of 10 over 10. So cosine of q equals square root of 10 over 10. And again, we're in quadrant 1, so it's positive. Everybody sort of okay? Alright, so now on the next page, we are going to simplify these trigonometric expressions in terms of sine and cosine. So what we want for problems A through F is to get down to where all that's left is one trig ratio, and we would like that trig ratio to be sine or cosine. Now, in just a minute, the instructions may change, but normally when we're doing trig, we want to get our final ratio down to be sine, cosine, or tangent. Sometimes you can't get it there, and if you can just get it down to one, but specifically on this particular section, they said sine or cosine, so that's what we want. Well, obviously, on A, cosine is already cosine, so I can leave that alone. But tangent, I'm trying to get rid of. So I'm going to rewrite tangent. So if you go back and you look at your identities, I could rewrite tangent as 1 over cotangent. That doesn't help me, because that's not getting me any closer to sine and cosine. Or I could rewrite tangent as sine x over cosine x. So that's what I'm going to do. I'm not changing the cosine x, I'm going to leave it just like it is. But tangent is going to be rewritten as sine x over cosine x. And now, I have a cosine on top and a cosine on bottom. So what happens to those? They cancel. So my final answer is just sine x. And that's it. See how easy this is? See how fun is this fun? Okay, so do B real quick. It's easy.
So I just cut it in for tangent, and then the cosines cancel out sine x.
We're third. No. I can't believe this. What does it say? No, we're third. We are fourth. We're fourth.
Do you know who?
Yep. Early is first. Cisco is second, and they're doing the board. Banks is third. We're fourth. Clyde's doing the Elephant Man. We're fifth. And Breckenridge is doing the deer.
Yes. So we can see where it is.
Awesome. Y'all do know that that's not. Y'all do know what
Yeah, I know
idea
it's like a
is.
funny one.
It's the Greek.
Yeah.
Yeah. It's very tragic. It's very.
That's
It's very intense.
So Breckenridge is the pretty interesting.
What is
At least
that?
the word
like
last year.
the story of Titus.
I'm kind of excited to see
The movie
Breckenridge
adaptation
after
that
like
played they did with Anthony Hopkins.
because they never
Crazy, and he murdered his dog.
I would like to too. I love that show. I love Miracle Worker. It's a really, really good show. Okay.
Good show.
So.
Right, the sine and
Do we get
cosine
to
for
watch
tangent, and then you must simplify it to the sine
the
and
first
cosine.
Oh yeah. We should have come. I think we'll be at the lunch.
It's like,
Okay, so you should have rewritten cotangent as cosine of x over sine of x.
Am I right?
And sine of x stays like it is, but then they cancel, so your answer is cosine of x. Easy? Awesome. So on C, I have secant and cosine. Cosine we're going to leave by itself. Secant, I could rewrite as 1 over cosine. Good. So I'm going to rewrite secant as 1 over cosine of x.
But doesn't that just leave it as 1? I thought
It
we were
does.
trying to get it as cosine.
I know, they should have included that though. That is one thing that happens with identities. They almost always equal another identity or 1. They can equal 1. They should have put that up here. Okay, now on D, I have secant over cosecant. So we're gonna have to probably do some keep switch flipping here. So I'm gonna go ahead and change them both. So I'm gonna change secant to 1 over cosine. And I'm gonna change cosecant to 1 over sine. And then I'm gonna keep switch flip. So I'm gonna keep 1 over cosine, switch to multiplication, flip. Now, if we're gonna do what their directions say, we would leave this as sine x over cosine x, because that's what the directions say. Write the expression in terms of sine and cosine. But I'll be honest with you, the trig teacher in me says, you should write that as tangent of x. Because if this was an equation, we still couldn't solve this, because it has 2 different trig ratios in it. But if you wrote it as tangent x, we could solve it. So, that just makes me feel better. Everybody okay? Isn't this fun? Okay, yes. Okay, so sine x, cosine x, those get to stay the same because they're already in terms of sine and cosine. We'll rewrite tangent as sine x over cosine x. And this time, I have a cosine on top that cancels with a cosine on bottom. Now I have 2 sine x's. Well, I don't have 2, I have sine x times sine x. Sine x squared. So sine, and I think I've talked about it. I never know which class I've said it in, but the squared goes after the ratio and before the argument thing. So, I don't know why, it just does. So it's sine squared x. Everybody good? Okay, so you do F and G. Do F and G.
plugging in numbers. And it gives me 5 over 13 cosine, so you just plug that into this equation. Because you're looking for cosine, and those 2 are both there.
Okay, so y'all get that far? And then I cancel my sine x's, and I'm left with 1 over cosine squared x, which according to their directions, you should leave it just like that. Which, if back before the inspires, we would have left it like that,
Yeah.
because this calculator doesn't have the other 3 ratios on it, so we would have had to have it in terms of sine, cosine, or tangent. But if you have the inspire, you could change that to what? Yeah, secant squared x. So, since you can put that in the inspire and you can solve that way. Oh, thank you. Okay, so on this one, Sin x stays the same, cotangent becomes cosine over sine, and secant becomes 1 over cosine. So, these sines cancel, these cosines cancel, just 1. Everybody good? Okay, so those are the easy ones. And so we're going to stop right there, because those are the easy ones. And we will pick up, I don't know what we're going to do, because I won't be here Monday.